Pattern Recognition App. In this section, we will develop and deploy in an Android app a model capable of distinguishing among different patterns. This can be very useful for text recognition. Some of the commercial applications I've seen using this technology are recommendation systems where you send a picture of something and they recommend you something similar based on the texture, such as floor tiles and carpets. In this video, I will explain our approach to solve this problem, show the dataset, and explain a potential way to make it work in an app. A very old approach to perform pattern recognition is using what's called Gabor filters. These are already around 40 years old, but still studied nowadays due to their simplicity. The idea is to convolve the picture with these filters. In a convolutional neural network, we are doing the same with some randomly initialized filters while we modify them during the learning to minimize the cost function. We will design a simple model I just came up with, so the accuracy won't be extraordinarily good, but it will be good enough to show the model is learning. The problem with more complex models is that they may take really long time to train them in regular computers. The input of our model will be a cropped picture of size 40 by 40. Since we will use 3 color channels, RGB, the shape of our input placeholder will be 40 by 40 by 3. In most cases, you might not need colors to distinguish between patterns. For instance, the texture of leaves, wood, fabric, etc. are very different regardless of color. In fact, color could be a distraction and could make our model unnecessarily complex. This depends on the application though, because for a floor tile recommendation system, we would definitely take colors into account. I decided to use color just for explanatory purposes, since the other tutorials we will only use grayscale images. Then we will convolve it with some filters and we will obtain 16 38 by 38 outputs. We will see in the code that the way to convolve the weights is the same as if it's a grayscale image. We just need to specify we're using 3 channels where we before specified was just 1. Then, in order to make the network more interesting and less repetitive, I decided to use branches in the graph. There will be 2 different branches doing the same operations with the same size. Afterwards, we will do a max pooling in each branch to reduce their dimensionality by half. And finally, we will concatenate them and reshape them into a one-dimensional tensor, and perform a normal feed-forward operation. The output layer will consist of 13 nodes because we are dealing with 13 different classes or textures. The dataset will consist of only 13 different pictures I took on my way to my workplace. Some of them are easily distinguishable because the colors are very different, but some of them are more similar or random. If I simply use these pictures to train my model, it won't probably be enough. In fact, if I only have 1 picture per class, how can I have training and testing sets? And how can the model learn properly about these pictures so that even if the input picture is slightly different, the model can successfully recognize it? The answer is data augmentation. Data augmentation is a very common technique in machine learning when there is not enough data. We will use a simple technique to increase the size of the dataset. In order to create the dataset, for every picture I will take portions corresponding to the size of the network, 40 by 40. Then I will modify the picture by rotating it between 0 and 360 degrees by steps of 10 degrees, and I will rescale it. And do the same operations, collecting only the portions that are not empty. This way, from 13 images, we will generate a dataset of several thousand samples, and from these we will randomly divide them into training and testing datasets. Now, there is one more thing to mention that we will see when developing the Android app. After we take a picture with the phone, we can do different approaches in order to recognize the texture. What I will do is probably one of the simplest. I will simply crop a 100 by 100 portion of the center of the picture taken, and I will resize it to a 40 by 40. The reason is because when someone takes a picture of something, he or she usually tends to put it in the center. Then another approach could have been just dividing the picture into a grid and passing to the model each of the portions to select the most frequent classified class. Another reason why I'm using portions is just because I trained the model this way, otherwise it won't probably work that well. And in the next video we will start developing our model.